Morning, everybody. It's jumping from one continent to another continent. I'm going to talk a little bit about my experiences in China. Then first I have to explain a bit about my own situation. Officially I work for a research institute which is connected to Wageningen University. That's an agricultural university in the Netherlands. Not at the university itself, but at the research institute, which is a good situation because I don't have to teach, only can do research. The bad thing is I also have to earn my own money with projects and not get money from the government. And one of my projects for the last years was that I was a representative of the Netherlands Soil Partnership in China. And the Netherlands Soil Partnership is a group of commercial companies, universities and political ministries and so on. And they want to promote the extension of the Dutch knowledge in China on a commercial basis. So this is the outline of my presentation. First I will give some specific characteristics of soil remediation in China, because the situation in China I will manage. I think both are not working, but maybe I'm not working. That's also good. That's a good one. That's the more serious one. Back to the basics. Okay. First, a bit about specific characteristics of soil remediation in China. Then something about heavy metal pollution in China. First, I want to talk about organic pollution, but I'm mainly working with heavy metal pollution myself, so it was more easy for me to change to heavy metal. Then about the research project we did in China under the umbrella of the Alterra Wageningen University research. Then the future, the new implementation we are going to do in Vietnam. Then a little bit about the research remediation funding strategies. And then a little bit about possible collaboration with Brazil, because that's also one of the reasons that I'm very happy to come here, because I want to try to make some connection between China, Holland and Brazil. So first, the specific characteristic of soil remediation in China. Now, very specific is that there's a strong emphasis on real estate development in urban areas. That means it has to be fast. If you go to a real estate company wants to start making apartment buildings or something, and then they know, okay, there's some pollution there. There are laws now in China that you have to do something with pollution. Then they ask some consultant and they say, okay, it will take us 1 year for site investigation, then 1 year to decide. After 3 years, the soil is clean. Then the company, real estate development, say, no, we wanted everything clean in 2 weeks. So there's a strong limitation. The real sophisticated techniques of soil remediation you cannot apply. That the only possibility is to dig and dump. That you have to take it away and store it on another place. Of course, that's only moving the problem from one place to another. But the economic development in urban areas in China is so fast that this is at the moment the only possibility. They, however, see that they have a problem for the future. They do the same with factories. They change it from the inner part of the cities to just outside the cities. That's also just moving the problem from one place to another. But there is, we can do something in this early stage. You can invest in waste decreasing techniques. In the techniques to reduce the amount of waste. I put here soil washing and catalytic oxidation. These are techniques in which the amount of waste you have to dump is reduced with a factor 3 to 10 or so. That helps, because then the dump sites get smaller and the problem to solve later on gets smaller. But on the longer term, there are techniques necessary to also to clean up the waste dumps, in fact. So at the moment you cannot do too much with sophisticated soil remediation techniques, because they simply have no time for that. But there is some new political attention for diffuse pollution in rural areas, because there was a report came out that more than 50% of the pollution in China is related to the pollution with nutrients, pesticides and so on in the countryside. So they first thought that the main pollution was in the urban areas because of the industry inside the cities, but now they also gain attention for the pollution in the rural areas. So there's also not only the diffuse pollution in the rural areas by pesticides and nutrients, but also the pollution which is related to the industrial sites in the countryside. They have a lot of very small pesticide factories which have been closing down, and they created around in the rural areas around the factories. They created quite a lot of problems. And there are a lot of mining activities in China: copper mining, tungsten mining, zinc, lead, copper, zinc, lead, and cadmium, because it's related to zinc, and also a lot of coal mining. So that must be also known here from the press that there's also a lot of accidents in coal mining. In fact, there's about 3 times the surface of the Netherlands which is considered heavily polluted, mainly because of the mining activities and industrial fallout in the countryside. So what are the short-term possibilities for pollution control in the rural areas? Develop schemes for active soil management, soil remediation in combination with the recovery of the economic potential of polluted and degraded areas. That's a very big need. They don't know very well how to do it. They just use some information from outside and apply it, and then another. There's not a very well defined policy regarding this. There's also phytostabilization, using natural vegetation and non-food crops. That's revegetation of degraded sites to combat erosion, which is a major problem in some areas in China, especially in the north. And in some cases, phytoextraction, phytoremediation. Heavy pollution in China. Now, which we have here, the main sources are it's the mine tailings and metallurgical industries, which many times are located, of course, in the countryside. Also, in many cases, the industry started in the countryside, but then a city was built around that to accommodate for the workers and so on. So it's a semi-urban area. There are a big problem with waste disposal in rural areas, especially chromium. Chromium received a lot of attention in recent years because really people died because of chromium pollution. And the government spent nearly $1 billion to solve the problem of the sources, but now there's still a problem of the soils which are contaminated with chromium. It's a major problem in China. And then also the diffuse pollution of agricultural soil, especially in the northeast of China, through the use of industrial wastewater. People can ask why use the industrial wastewater. That's very simple. That's the only water which is available. There's a very dry area with a lot of agriculture, so they need the wastewater, also the industrial wastewater, to irrigate the agricultural soil. It's too expensive to clean the wastewater. So that's also a big problem, and still continue. They're still increasing, accumulating the pollutants in the soil. Now we go to show some pictures to see about the situation. I put here 5 places, 5 areas where we have been working. 4 of them in China, and 1 is just over the border in Vietnam. First we go to Shantou, which is in the southeast of China, in the booming Guangdong province, and this area has nearly a tropical climate. I think the climate is quite comparable with this area around Rio de Janeiro. The differences between summer and winter are a little bit smaller, I think. And the place I visited there is a tungsten mine, wolfram. How do you call it in Portuguese? Wolframio? Yeah? Yeah, because many people don't know what tungsten is. They have a mine near Shantou, And this mine is causing, because one of the side products, one of the always companies with tungsten is arsenic, so they have quite a substantial arsenic problem. There's about an area of around 1,000 square kilometers is polluted by arsenic, and this arsenic leachates are also very acidic, which adds to the problem because the bioavailability of arsenic also increases. Here a few pictures I made. Now first you see it doesn't look too healthy, the soil, and what they are doing, and I think that is the best approach for their situation, is that they make whole structures of canalizing the flow of polluted water, and put it through small ditches and then go to canals and then let it go to the sea, because that's not the impact on the sea is very limited, because the amount of polluted water can be accommodated by the especially because it's arsenic, can be accommodated by the sea. It's not a considerable sea pollution because it goes slowly and slowly. But there are problems. The government has only limited amount of money allocated for this, and so there's a problem with this canals. This is the end of the road nearby the sea, and you see there's a lot of water plants growing there. Pretty soon there's a lot of they need to clean up the canals. There's also a problem with typhoons in that area. That sometimes there's a lot of water coming down from and then the canals cannot manage it. The water flows over and pollutes the neighboring agricultural areas. So there are in fact two problems. That's a natural problem because of the typhoons. The canals should be better protected, but for that you need money, and the money is not given by the government. That's the major problem. And we can do something, for example, to decrease erosion and leaching processes, for example, by revegetation. The mountains there. And you see on the left side they did some very basic revegetation experiment. They tried to put miscanthus, which is a high growing grass with very big root system, which is quite effective at erosion. You see they do some experiments there, but they are not very well carried out. They just put the plants there and see what happens. But because the soil is so acidic, you have to do something before you can really put this grasses. Also, they do a lot of work on field sites which are moderately polluted by arsenic. So they do crop uptake experiments quite a lot. Now I move to a completely different part of China, which is in the north, so in between Mongolia and Tibet. It's a very different climate. It's a continental climate. So in the summer it can be quite hot, up to 40 degrees, but in winter it can go down to -20. So vegetation is very scarce. It's nearly a semi-desert, at least this part of Gansu province on top. And also here there's a lot of, in a city called Baiyin, which means white silver, but it's a copper mine, but it's named after the company which was by coincidence was called White Silver. And there is now a long time copper mining. This whole city, Baiyin, was just created around the copper mine. It's now 500,000 people, but now they closed down the copper mine. First I thought that they would then also close down the city, but they're extending the city, so they must have found some other way of living, because the agriculture is very poor there in that area. So I thought that would become a dead city, but there is a strong, around the factory is a strong copper pollution and also fluoride pollution. And you can think it's funny, but I saw their sheep without teeth because there was too much fluoride. Sometimes you see a really white cover of fluoride on the vegetables. Fortunately, the people in the villages are already connected to the central water supply from the city, so they have clean water. But if they would use the water from the wells nearby their house, they would also have this teeth problem. because fluoride is good for teeth in small concentration, but bad for teeth in high concentration. And really, 10,000 ppm, 20,000 ppm, that's quite normal to find that in the soil. So the pollution levels are so high that agricultural production is really affected by the contamination of the crops. Now I have to remember which one it was. Yeah. Here, for example, this looks like a bit strange mountain, but it's a big waste dump. And not so many heavy metals inside, but even more fluoride. You can see it on the floor. It's just go by wind, but still using it. They put lorries go up waste material from the copper mine there. And here you see agricultural area nearby the copper smoke. In fact, the mine is not here. The mine is about 10 kilometers from there. That's also, I don't have photographs of that, but also very, very bad. But looks worse, but there is no agriculture nearby, so it was not that much interesting, but it's more polluted even. The mining area itself, here nearby the smelter area, is also quite polluted. Now you can see what it does with the agricultural soil. You see the waste dump once again. Place you see here the fluoride. And nobody could explain us where the fluoride comes from. I tried to find out, but nobody knows. In last month, 2 months ago, we made a collaboration agreement between this Netherlands Soil Partnership and the officials in this Gansu province. Gansu province is comparable with a state in Brazil. Nearly 30 million people live there. And so it was very well established, this collaboration, because it was really supported by high officials. That's why I had to appear here in those very nice clothes, which I normally don't like to wear, but it had to be so because everybody you see walks around here. This man here is more or less he's the vice governor of Gansu. And in China, the governor is less important than the vice governor. The governor is just the official figurehead, has to smile, and the one who really does the work, the vice governor, this guy. And this guy before was head of university. So he comes he has a strong research background, and it's quite remarkable on his CV. He clearly states that he is not a member of the Communist Party. That's also funny. Anyway, he is the big boss there in the Gansu province. And he supports the collaboration. That's very important because he spent quite some time also, he himself, on setting up this collaboration. So now the people there have to work because they are not only chased by the Dutch from the Dutch side, but also chased by their own bosses. So it's a very good situation. I'm expecting quite a lot. And mainly to solve the problem of agricultural area nearby those mining activities. They already started before the collaboration, and here in Chinese it's indicated that is the collaboration between Gansu province and the Netherlands. And the international collaboration, I think, can be extended, especially on the fields of the heavy metal uptake by plants, energy crops, ecological restoration. So this can be an area in which there can be some collaboration with Brazil as well. The only problem is that the climate is absolutely not known in Brazil, but it might be interesting and challenging anyway too. Now, the third place, Tongling. Tongling means Tong means copper, and Ling, this Ling at least, because there's a lot of Lings in Chinese language. This Ling means tomb, so the burial place of copper. And this is already a copper mine. I state here that it started 2,000 years ago. That's a mistake. It started 2,500 years ago. And all those 2,500 years, they were accumulating mine waste, mine tailings, in one place. So it is here. The copper mine is behind this mountain. And this area in 2,000 years was created. Some places it's 60 meters thick of mine tailings. So the residues which remains after processing the ore. Moreover, Here are the copper mine tailings. Behind there, they started, just behind here, started some illegal gold mine. This sounds familiar for the Brazilians, I think. And they also processed the gold there, and this creates a lot of arsenic pollution nearby. Here, they even put here some wells. The wastewater is simply coming over the land. So it's very strong pollution. This copper is very acidic. This arsenic is very acidic. So the problem is that those mine tailings, when nothing is growing, in fact, it's bare already for the century. And because of the wind, also heavy rain, they function as a source for pollution for agricultural areas nearby, because they lie lower. You have the mountains, then you have the big layer of mine tailings, then there's some small ditch they made in the time of Mao Zedong, which is not really helping, and below that's a densely populated rural area. There's a lot of rice farming and so on. And now gradually the rice stops growing because of the copper. It's not a real human health problem, but it's mainly phytotoxic problem. The plant doesn't want to grow it. And a good solution for that would be, in our opinion, revegetation. Manipulate this mine tailings in such a way which is not easy, because in fact it's not soil. The organic matter concentration is about 0.05%. So it's nearly only an inorganic material. Soil fertility can be considered zero, so there has to be done something to get some revegetation there. But it would be useful, because then you really can stop the 90% of the erosion and the leaching to those areas. Cleanup is absolutely not an option because there are billions of tons. You cannot clean up that. And then we started together with my main partners in China. We started a research project, and I will later on talk about the results of this research. We started in 2006. Here you can see that this is one of the candidates for the revegetation. It was the only example of a plant, this is a miscanthus variety as well, which managed to survive on this barren land. You can see this is nearly nothing growing there. And this was a group of 3 Dutch and the rest Chinese co-workers who visited the area in 2006, starting the project. For the moment I go to a fourth place. This is Fuyang Valley, the quite prosperous Zhejiang province. This has a subtropical climate. It's comparable with the south of Europe. It's a little bit sensitive for typhoons as well, but not as much as more southern areas here, near Taiwan. And it's, as I say, it's quite a prosperous area. It's one of the richest provinces in China. The area where we went, the Fuyang Valley, I say was, because at present it is not anymore. It was a small, relatively poor agricultural area, mainly consisting of paddy fields with a medium-sized zinc smelter located in the valley. So there was farmers, there was one zinc smelter with its workers. Not a very big zinc smelter, but a medium-sized one. So, at the moment I say was, because at the moment it's not relatively poor anymore, this area, it's rich now. It's not agriculture anymore, it's because agriculture is not anymore possible. And and there's also no zinc smelter anymore, so that's why I put here was. Everything I indicated here has been changed in time. After a few years ago, the smelter closed, so the farmers took another initiative because they had to find a new way of earning money. And they did something very clever. They started to collect copper residues from other smelters. They even collected it from 500 kilometers from there. They also collected waste from electric companies, electronic companies, that means the copper wire residues and so on, brought it to their valley, and then used a very old 2,000-year-old process they mixed the copper residues with clay and with lime. They made balls out of it. That was the work of the farmer ladies, and then the balls they put in some type of a pyramid and just heated them below in very small smelters, and that still could get quite a lot of copper. Here you can see collection of the copper balls. First make balls, then they put them. Here's a small factory. They have a lot of them in this small valley. Quite a lot of these small zinc smelters. Just open air furnaces to heat those balls, and then the copper comes out. That's an old process. I don't exactly how it works, but it works well, because the result of this all was that the farmers got really rich. You see beautiful houses, and everything looks very wealthy now. And before it was quite a poor area inside this prosperous province. But the other side of the medal is that the agricultural land is completely or nearly destructed, and it is not possible to grow rice anymore. So there is a need for measures from the side of the local policymakers, because this cannot continue. Well, what to do? What to do? You can close the small smelters, but then the farmers get poor again, and even poorer, because they cannot grow rice anymore, and they have to find something else. It's a small valley, but it's locally it's a big social problem. They cannot do it. Simply close the smelter. Another possibility would be to improve the smelters, that they don't emit so much dust containing heavy metals. But then the process becomes so expensive that it's not profitable anymore. So also that's not an option. So in a democratic process, the farmers together with the local authorities decided that the best solution for the moment was to pick up the small copper smelters, concentrate them in one part of the valley. It's about half a square kilometer, and do all the copper smelting there. That means instead of destroying the whole valley a little bit, they will destroy only a small part very well, and then the rest can still be used. And I think it's a compromise between social aspect, economic aspect, and environmental aspect. So if cultivating rice is not possible anymore, because the soil is polluted, but not that bad like in the earlier mentioned Tongling site, where it's really mine tailings, but the soil is not very suitable for food crops anymore. So maybe growing energy crops or other non-food crops can be a solution. And therefore also we started this ENCROP project, and here I put it once again. The objective of this ENCROP project for both, we did work in both this Tongling area, the mine tailings area, and in the, let's say, the copper balls area. And it's in fact the assessment of the economic and environmental potential of energy crops on heavily polluted areas. The funding is from the Dutch Ministry of Economic Affairs, because the objective was to create business opportunities for Dutch companies in China. And the connection with that is this crazy Kyoto Protocol. If the Dutch let's say, reduce the use of the emission of carbon dioxide in other countries, they get benefits and they earn money for that. So it's in fact exporting of pollution. It's a bit strange process, but that's the reason why Dutch companies became interested in this option. Okay. Now I will focus more on this ENCROP project, and the content is, I start first with giving a background based on earlier European projects done, coordinated by Alterra, then give some general aspects of energy crops, give very shortly the research approach we did to evaluate this, then an overview of the results, the research results in Tongling, in the mine tailings area, and after that in the let's say, the copper balls area. First goes some background. This phytodec project was ran between 2003 and 2007, I think. I remember well, was a collaboration project inside Europe to investigate the possibilities of different type of phytotechnologies. That means phytoextraction, phytoremediation, and also phytostabilization. Do a lot of experiments. It was a collaboration between Spain, France, Bulgaria, Czech Republic, Italy, and Holland. I think that's all. So what one of the objectives of this phytodec project was to see at the possibilities of ecological restoration of heavily polluted, metal polluted soils. And the reason for that is to decrease the spreading of the heavy metals to non-affected areas through reducing the leaching rates, the runoff rates, and the wind erosion rates. And also to block or to reduce the pathway to receptors. That means do something with the soil in which not too much heavy metals are taken up by the plant, so that it doesn't enter in the ecological food chain. That rabbits start eating that, then we eat the rabbits, and then etc. So there were no energy crop related objectives at that time, but the results of this phytodec project can be used as input for the follow-up project in China, which was focusing on energy. Now here's some results. There are also results which are not so nice, so I only put a few nice results. There was a heavily polluted area, copper area in Birtop in Bulgaria, and the only thing we did was just to add elaborated mixture of waste materials and fertilizers to the soil, consisting of zeolites of lignite, which is some type of carbon source, and a dedicated fertilizer combination. And then after a few years, that means 1.5 years, all the natural grass vegetation started coming again. It could be even used to feed horses in the local area. It was not toxic anymore. So it was quite successful, because this area was already barren, without any vegetation for quite a few years. And even there in Bulgaria, people died because of this, because the runoff went directly straight to the drinking water supply of the town. And now I don't know if people died because of it, but people got insane because of the arsenic pollution connected to the copper mining. Another striking example is in Poland. There are also mine tailings with 3 to 5 and sometimes 10% of heavy metals, so that's percent. So it was really nearly recoverable if it would not be such a mixture of heavy metals. So it's absolutely. Only thing we did was we added lignite, which is a carbon source, and rock phosphate, and after a few years simply appeared the natural vegetation of this area, and these were heavy metal resistant plants which were able to survive high concentrations of heavy metals. But in a few years they simply appeared there, and now I've seen this area a few years ago, and it's now completely covered with natural vegetation again. And that's a success, because before that it was area nearby a residential area, children playing there. Now children playing with soil which contains 3 to 5% of heavy metals is not good for health. But now at least it's covered with the vegetation. So let's say the chances to take up heavy metals are reduced now. So after the good results of this phytodec project, we proposed to another project to evaluate the potential of energy crops on polluted, degraded land in China. And that the reason was that I had personal reasons to want to work in China. That was the reason for China. So that this to produce not only carry out revegetation, which has only an environmental objective, but also try to create some economic benefits, and preferentially local. So economic benefits for the local population, that would be another advantage. It would be a win-win situation. It was financed, as I said, by the Ministry of Economic Affairs because we simply we made the project in such a way that it looked like we were busy to promote the possibilities of Dutch companies in China. Okay, some general aspects of energy crops. In fact, you can distinguish three types of energy crops. One of the three you are very much familiar here in Brazil. The first one is the biodiesel producing crops. That means oils. Now very famous at the moment is this Jatropha and Ailanthus varieties, plants who produce oil, which can be mixed generally up to 5-10% with gasoline. And that's in China, Vietnam and Thailand. It's already quite common. You can find B5 diesel and E5 gasoline, in which the gasoline is mixed up with this oil. It's to reduce the dependence on fossil energy. And of course, then here the ethanol-producing crops, sugar-based, starch-based, and in the future probably also cellulose-based. And then the more direct one, that's biomass-producing crops. That's wood production and high productive grasses. Energy crops on polluted, degraded land. Why you do that on polluted, degraded land? Polluted, degraded means it has some agricultural, agronomic challenges. It's not easy. It's not very fertile. But to do it on fertile agricultural land in countries like China, Vietnam, Thailand, and the whole east of Asia, it's absolutely politically unacceptable. There is so much shortage of good agricultural land for food production that it's simply not allowed by the government to produce energy crops on good agricultural land. That should be used for food production because the people need food. Especially China is very special in that they want to be autarkic. They don't want to be dependent on import of foods. So you really cannot even start discussing of having a more economy based on importing certain things and exporting other things. They want to produce enough food for their own population. They don't want to be independent. So this is out of the question. They will not allow that in China. So if you want to do something, then you should work on polluted, degraded land. But it has also a lot of advantages because the land is very cheap or really of no value. Erosion control is a very important environmental benefit. Problem might be the crop quality. If there is a lot of heavy metals or so taken up by the crops, then even for energy crops is not an option, because then if you make energy out of these energy crops, then the heavy metals can go inside in environmental cycles once again. The Chinese national policy is also quite strict. You cannot use energy crops on land which is suitable for food production, like I said. It's also not allowed to use food crops for energy production. So what you do here in Brazil would not be allowed in China. The sugar should be used for sugar. The sugar cane should be used for sugar or strong drinks, but not for put it inside cars. And also in the United States, also they use corn to produce energy, with the effect that the food price, the corn price for food, has now tripled. I think it's 3 times higher than it was before. So it's not allowed. Also, they like in certain areas in China, they like to have energy sources which can be used at the local level. So they don't have to transport a lot of fuel from one side of the country to another side of the country. Okay, something about the research. Now the research approach was that we had to find out first, because this polluted, degraded land, there is no vegetation, or the vegetation is is not functioning very well. So you have to do something with the soil, and we have to find out what to do in a specific situation. So we needed to design protocols to find out which is the additive, absorbent, or fertility improvement which is the most suitable for a certain site. And we have to check whether the energy carriers, which is the sugar or the oil, by themselves are not getting polluted with heavy metals. And we have to look at the economic viability. Now, just to show you what experiments have been done during this project, quite a lot of experiments. We did, for example, to find out the toxicity of the soil for plants. We did standard root elongation tests. Maybe some of you also are familiar with that. What you do is barley seeds, you put them under very well controlled conditions of temperature and humidity, and you let them grow in the soil you are testing. And barley seeds, the germination of barley seeds is very sensitive for pollution. So it's a very sensitive tool to find out if a soil is potentially phytotoxic or not. So you can see here the different treatments that the plants on the left side are quite healthy. The root length is quite okay, but here the root length is very limited. And there's an indication that the soil, when like this, when used for other plants, also will be phytotoxic. And then after that, these were the preliminary experiments, because it cost only a few days and you can test a lot of different treatments in a short time. Then you do the treatments in more or less real life situation. You do pot experiments with the lysimeter experiments with the soils, which came out as quite good here with the tests here, just to find out how it works with the plants you really want to try in your experiments. Then something about economics. We had to show that it can be economically profitable, production of energy crops on polluted land. So we had to use the oil price. It's a little bit complicated. I will not give too much attention because you are not economist. I'm not too. That what we calculated here is the price of oil. It was at that time at least €100 in 1 for 1 ton. Energy density, the amount of energy you can get out of 1 ton. This gave an energy price of about €3 per gigajoule. So, if this energy crop would be competitive with, has to be competitive with oil, has to be the same price or cheaper than oil, otherwise it's not worthwhile to even try it. That means if you look at this miscanthus, it's one of the candidates, it can get around 60 tons per hectare per year. The energy density is 18 gigajoule. I put euro here, but that's not correct. It's 18 gigajoules per ton. So the price of the miscanthus should be not more than to produce it should be not more than 54 euro per ton. Now, and here some indications that we used for the calculation. We used lower than the oil price based minimum price for the miscanthus, but we used a lower value because China has still a lot of coal, and coal is cheaper than oil, so it has to be competing not only with oil, but the better would be that it would be competing with coal as well. And we have two different calculations, one based on 60 tons per 60 euro per ton, and one for 20 euro per ton, because the oil price since the beginning of the project increased quite a lot. Now then you do here some calculations about investments you have to do, recurrent costs and so on, all using labor costs as common in China at the moment. Then depending on the most conservative and the most pessimistic and the most optimistic, in the most pessimistic approach with the high, the low oil price and coal price, then it takes 12.5 years to get your investment back. And in a more positive, which is more realistic one, then after 3.5 years you get your investment back. And if you take into consideration that the miscanthus can be productive for around 20 years, this would be marginal. But this would already give good revenues for farmers. So it's a little bit on the edge. It can be working okay, it can be not working okay, depending on the oil price, for example. And also depending on the economic situation in China, because the salaries are going up. That means that the labor costs go up, then it can also be less profitable. It's just a short overview, but we did a very thorough economical analysis on this. Now some real results. We go back to this Tongling site, this mine tailings area. And just to remember which site it was, I put the same photograph here. Then we designed quite a big experimental area, which was on the border between the area which was only affected by the copper mine tailings and the area which was also affected by the illegal gold mining, that area which caused a lot of arsenic pollution and acidity. And that was just to test a worst case situation. Just we wanted to see when energy crops and other vegetation was not able to grow anymore, whatever we did. So just an indication of this area, this area here, I put it here as in a scheme. And here you can see that the copper concentrations are higher in the area which was only affected by the copper mine, of course. And you see also quite a lot of variation, that because when dumping mine tailings, the mine tailings don't have all the time the same pollution level. That's quite a lot of heterogeneity. That's one time you put some very clean mine tailings, one time you put very polluted mine tailings. That's why the variation is quite substantial. And you see the area which was mainly affected by the gold mine, the copper concentration is very low. Before, the copper concentration was also high probably, but because of the acidity, the copper has been leaching down. So there's no copper more in the upper layers. With the arsenic the other way around, the arsenic concentrations are low in the, of course, in the copper affected area here, but are very high in the area directly affected by the illegal gold mining. pH is okay, that means neutral to alkaline in this area, and acidic in the area affected by the gold mining. pH in some places was 1.5. So that's serious. So what we did, if you look here at the copper concentration in the, because we were focusing on copper and not on arsenic, if we look at the copper concentration, the total copper concentration in the on the field site, that was translated in an available copper concentration, which was the other way around. In this area, relatively low concentrations of copper, but because of the acidity, the plant available concentration is very high. So the plant available concentration in the area with the low total copper concentration is higher than the available concentration in the alkaline area which has a high copper concentration. I hope this is not, because if you're not familiar with this, then it might be complicated. So the situation in fact is that it doesn't matter if the concentration of copper is very high. If it's alkaline, then it's not a problem. If the concentration of copper is high and it's also acidic, then you have a problem. But there can be situation in the copper concentration is relatively low, but because it's very acidic, it's phytotoxic for the plants anyway, because it's available for the plants. So we did some soil amendments. We added, in fact, simply added lime and rock phosphate and a reasonable amount of NPK fertilizer. And then you see that the plant available concentration, just because of pH management, went down in most part of this area. Only the area most nearby the well was not enough. Those were the areas where the original pH was around 1.5. That didn't work. We didn't put enough. Now, then we did some experiments with plants. You have to know, before that, nothing growing there. It was absolutely bare for not for decades, for centuries. So we were happy to see that at least something was growing here after putting those amendments. So there was some plant growth here. It's also sustainable. It didn't die off after a short period. But it's not enough for energy crop production. That's the situation there is too bad. Those plants are too small. Of course, you cannot get any profit out of it. It's not gives 1 ton per hectare instead of 60 tons per hectare. And you see there's also a difference between the high pH area and the low pH area. Low pH area plant growth was very marginal. In the high pH area it was started to be acceptable. So the interesting thing is now that this area, the energy crop production, was not very successful. We didn't also expect this because this was really not a soil. It was a very polluted mine tailings. But the interesting thing, which we did not expect, that after finishing the experiment, even 4 years later, the natural vegetation on that area restored. So there is now, it's now covered with a quite dense natural vegetation. So we did not meet our energy crop objective, but by accident, coincidentally, we attained ecological restoration objective. And therefore the local authorities now, I heard it only a few months ago, are becoming very well interested. They really want to do something with this area, which is about 5 to 10 square kilometers, and really affecting the neighboring areas. So they want us to make a plan combination. When it's not so very well polluted, there can even be food crops grown. When it's more polluted than energy crops, if it's very polluted, ecological restoration. To make a plan for that on the basis of a monitoring of the whole area. Here is shown how the natural vegetation is starting in between it's some islands start, and then it covers the whole plot. Results from Fuyang. This is this copper balls area I mentioned before. Now here you can see it once again, copper balls and the makeshift copper smelters, which caused the problem. Here we tested 4 different crops. Sweet sorghum, which is in fact sugar producing crop. Sugar cane, I mentioned before that sugar cane cannot be used for energy crop production. Only it can be used if the sugar is not fit for human consumption. So if it's only suitable to make alcohol, industrial alcohol, then it's allowed. The other is called Chinese sumac, that's a biodiesel producing plant, and we used vetiver grass, which is deep rooting, high productive grass, which is at present used quite a lot for erosion control in Africa and also in Asia. And the roots of this vetiver plant are used as a product to be used for the perfume industry. Raw material for the perfume industry. And of course the Chinese also make Chinese medicines out of vetiver grass, because they make Chinese medicines out of everything. I give here indication of how we did it. We did just statistically inside one area we selected a random selection of where we put the different crops. Quite a big area. Then we did first an analysis of the soils in the test area. you can see that this is the copper concentration, this is the zinc concentration, this is the pH, this is the lead concentration, this is the cadmium concentration, and you see there is quite a variation between the sites which we expected. Both regarding copper, zinc, cadmium and lead, this area is the most highly polluted. This area. And this is because this area was the nearest by the zinc smelter. And the wind south east, so the area northwest of the smelter is also still quite polluted. It's the same for all the heavy metals. And on the other hand, you see that the pH is quite high in this area, but in the area which is relatively clean with heavy metals, the pH is quite low. So we had to do something with the pH. We limed it, added phosphate, we made 4 blocks. Here only added lime, here a combination of lime and phosphate, here only phosphate, and here this is a control. It started not working too much. Anyway. Okay. Adding the lime and the phosphate, the amount of plant available zinc and the amount of plant available copper were reduced. So it's now a more agriculturally favorable situation. The uptake of the heavy metals will be not too high probably, and also the phytotoxicity will be acceptable. We looked at the uptake of zinc and copper by the crops, and we can see that if you remember that here the highest concentration of zinc and copper, the highest total concentration, but because of the pH effect, the concentrations of the available copper and zinc are highest here, and also the uptake of the copper and zinc by the plants is the highest in those areas, which are not areas which have the highest copper and zinc concentration. And the interesting thing is that this is completely coincident with the biomass production. Biomass production is much lower in the areas which are affected by the bioavailable zinc and copper. This is nearly a proof that it's a phytotoxic effect of copper. Not completely, there can be another discussion is possible, but nearly a proof that these levels of copper are already toxic for plants. So if you work with copper polluted soils, then the concentration of bioavailable copper should be reduced. Otherwise, we don't have a chance. Anyway, there's a comparison between the different crops. You see that the concentration, the uptake of zinc and copper for the sweet sorghum is by far the highest. And it's more or less on the acceptability limit. So it may be that vetiver grass probably is the best alternative for this area. So the results indicate that the energy crops grow well on the moderately polluted soil in the Fuyang Valley. The heavy metal uptake is not too high for the crops. And the pH is very important. You have to control the pH, therefore control also the bioavailable heavy metal concentration. Now the conclusions were that the energy crop production on polluted and degraded land is viable if conditions are not too unfavorable. In Fuyang it's very well possible. So we came to the conclusion that the results can now be implemented on a somewhat bigger scale. So we want to go from the test scale to the real implementation. So what we did, we made a project proposal for China to implement the results, but it was rejected because we put the Chinese as the leading partner, and they didn't have enough confidence in the capacity of the Chinese partner. So we decided to do it the other way around, to propose the project once again, but now to another program which was more connected to Vietnam. So we decided, Chinese and my Chinese colleagues and I, we decided to both together have a project in Vietnam now. So the Chinese also now have a project in Vietnam. That's very good also for the bilateral relations, because it was not so very good last time. They are fighting a little bit about water supplies. So we have now, since September, we have, together with the Chinese, we have a project in Vietnam, and I want to tell you a little bit about that also. So the future implementation in Vietnam. And the project objectives are completely different from the research project, because we are not doing research anymore, we are doing implementation of research results. So we want to implement the research we obtained in earlier projects. So the main targets of the project are to have a demonstration site. We want to have a demonstration site of how it works, because our experience in China and Vietnam is that if you show something to the farmers, it's not necessary to convince them by speaking. They will imitate it, because if they see it works, they really will imitate it immediately. So it's important to have a good demonstration site, to involve all the stakeholders, so the mining companies must be on board, that we managed to do so. We want to construct a training center at the farmers level, at the on site, so that farmers don't have to travel to get information about this energy crops. And we want to, at a higher level, we want to develop a curriculum. In fact, we are already busy. A curriculum on energy crops given to students at Hanoi Agricultural University. Now we go from China, from those areas, to this coal mining area. So we've chosen a coal mining area because that's a major problem in Vietnam. In the area in the north of Vietnam, where 90% of the coal production takes place, there quite a lot of natural areas are really devastated by the coal production. I will show it in the next Google Earth pictures. First, I zoom in a little bit to show you the geography. So here is China. It's very nearby the Chinese border. For example, this Shantou is here, where I also did the tungsten mine, the first example. So it's in that area. This is the tourist area of Hainan, which is developing very fast and will be a major tourist destination. Here is Hanoi city, and this area we are focusing on is a little bit nearby Haiphong. And this area, this Halong Bay, is a very famous tourist area. That's why I put some tourist pictures here as well. They have all those strange rock formations in the sea. I think they have 2,000 islands. It's a UNESCO heritage site, and it's one of the major touristic areas in Vietnam. It's very beautiful, in fact. Now, look at this, focusing a little bit more. We have here the area of Halong, where a little bit to the left is this tourist area. You see a lot of small islands still here, also make part of this national park, and we have the Kampa area. The city of Halong, you can see here, the gray areas here is the city of Halong. All the other gray areas here, coal mining. You can see it from space. And the same with Kampa. It's quite a big city for Vietnamese. It's about 150,000, stretching along the coast. And all those areas here, all coal mining. The gray areas, coal mining. Focusing a little bit more. Here you see a coal mining area in the Halong area. You see this is still okay. And here they have been digging coal in day mining. That means surface mine. And they completely replace one mountain with another mountain. Then when there's coal nearby the mountain, they take off the whole mountain, put it somewhere else, and then dig for the coal. This is the same in the Kampa area. You can see the city here. And next to the city, you see the coal mining area. So it's completely destroyed, and it's even dangerous because it's a mountainous area. If there is a lot of rainfall, typhoons and so on, all the mud and rubbish can go over the city. So we're now focusing on this area. It's nearby the city, on the edge of the city. You can see that after 10 years or so, that in this area, this is all terrace of mine tailings, coal mine tailings, that the natural vegetation is at some places coming back. When it's very densely green, then the local farming population put acacia trees there. But even when here a little bit less dense, that after 10 years then gradually starts, some species already start coming back. But it goes very slowly. Here you see a view from this side, but now looking to the city, you can see this beautiful mountain area below. That's the islands in the sea. And this side, we're sitting on the edge of the site. This side we will transform into a demonstration site. You see it's still nothing growing there. Behind there all the areas still affected by the coal mining. There has been done already some research experiment which is very helpful for us, but you can see if you want to make a demonstration site, you have to be sure that you will be able to demonstrate something. You have to be sure that it's successful. And so fortunately there is a German PhD research project on nearby site, which is the same coal mine waste as the site we are doing, and they did a plantation of this vetiver grass. It works quite well. It's now yellow because it's the winter season is nearing. Then it gets dry, but it's still functioning. It did not get very high. Many times the vetiver grass can get the roots down to 4 meters. This is only 1.5 meter, but anyway, it's 1.5 meter for roots. It's also not bad. Here the acacia trees do quite well, and the farmers like it. The local farmers like the acacia trees because they not necessary to use them for wood for burning, but they can bring it to a nearby paper factory and get money for that anyway. But the interesting thing is that this miscanthus, which is standing here, is also one of the crops we want to test. It appeared there naturally after putting the vetiver grass and the acacia. You see from some places this here was not planted or seeded. It's in 2 years it appeared here. So that's very promising because we want to test that one too. And this was done with nearly no soil improvement. They just planted it. So it's when you do something, it can work. And then we make already a scheme in where we will test 6 different crops. This is the miscanthus, local variety, for not having the problem with invading species. The sweet sorghum, the jatropha, because it's very popular in Vietnam and elsewhere to produce biodiesel. Ailanthus, that's a Chinese version of the jatropha. We want to test it also. It's also not invading species in Vietnam because it functions there. Acacia we included after the project was proposed because the farmers are interested in it, so we will test it also and try to improve the conditions. Cassava, the Vietnamese like to use cassava for ethanol production. And this vetiver grass, because this vetiver grass can be used for energy production, but is also used for erosion control, which is important, and can have side products which are also quite valuable. And the field site will be 2 to 3 hectares. The first demonstration will not only focusing on the field site and the performance of the crops. There also will be the devices to produce for a local level the energy from the crops. We'll also demonstrate how to make on a local level alcohol from sugarcane, from sweet sorghum, and to get the oil, to get the biomass. So very shortly, biodiesel producing crops. This is the picture of the crops we wanted to focus on. This is ailanthus, which can become very big trees. And this is an example of a very simple oil expeller made in China. You can buy for 300-400 euro, and which is quite effective in getting the oil out of these plants. Ethanol producing crops. Now here's just an example of what you can do with the sweet sorghum. If the sweet sorghum, you can use a simple oil press here, and and you obtain the sugar, and then you can just make the distillery like you are used to do here in Brazil as well. Also, it can be used directly if the concentrations of heavy metals are not too high. You can make products like this. In America, they like to use this syrup made of sweet sorghum. Here's an article about cellulosic ethanol production. Until now, the production of ethanol from cellulose was considered very complicated and not. But now they are starting to make real commercial pilot projects, and this is an article from the beginning of this year about this, and they are really starting to make pilot factories to produce ethanol from cellulose, and that means that you can produce ethanol from every waste product you can find. Waste from corn, waste from whatever, you can also always transform inside ethanol. And until recently it was more or less a dream to make it like this, but now it starts working, and the interesting thing is that the first big pilot factory will be made in China. This is Kennedy's technology, but the Chinese do it. And they will have they say it already starts producing thousands of tons of ethanol, but I don't have the details. I heard it. And it's also interesting, I didn't leave it here. Okay. Biomass producing crops. Those grasses can be 4 meters high. They are perennial, so they continue to have their erosion control benefits. But you can cut them every year. You just wait until they get dry in winter time. Unfortunately, also in Vietnam there are winter and summer seasons, so they will get dry during some part of the year. And you just can burn them directly. But the best way is to press them inside to make some pellets out of it, and those pellets made out of miscanthus have nearly the same quality as wood. In Europe, for example, they are also used. In Switzerland, they produce quite a lot of this miscanthus, and they are used for fires. When people in the house have a fire to heat the house, the natural fire, and then they put this miscanthus blocks inside instead of wood. It has nearly the same benefits as wood. Now here you see the vetiver grass. Here you see in the middle picture, you see how big the root system can be. You can imagine that is quite effective against erosion. Could even ask, where is the soil? So they use it here in the left picture on the left side. That's used for the erosion control. They put it in rows. It's a bit expensive, but it stays there for 20-25 years. But also in certain areas which are typhoon sensitive, they put it on the slopes of highways to avoid that it comes down. It's cheaper than putting it, and cheaper and more beautiful than put the concrete. They have the problem that it's quite expensive because you have to put seedlings there. So. But if you use it for energy production, I think the distance between the plants can be a little bit bigger because they grow in the wide. For erosion control should be very thick. And here some examples of these pelleting machines. The left one is a very simple one. You can also get for a few €100 in China. And that one is a bigger one, which can be used for example, at a village level or town level. It's also possible to transfer the leaves from this miscanthus into gas. Gasification units exist in many places in China, in which agricultural waste material is transformed in gas, which is mainly a mixture of carbon monoxide and hydrogen, which is then pumped into some canalization system for the whole village. So they have people collecting the waste, the agricultural waste, bring it to this small unit. It's transformed into gas. It is brought to all households in the village, and the people can cook and warm the house on the basis of the waste material produced in around the village. You can also do it in a more commercial way. There are bigger units also available, in which you can simply produce gas out of this waste material, and the miscanthus can be introduced as a high quality waste also in this type of installations. That was my story about Vietnam. Now very shortly about the different possibilities to get funding for projects, both research and implementation. It's very important, and that's my experience from the last years, very important on how you write a project proposal. If you can give it an economic objective, you can give it an environmental objective, you can give it a social objective, and then you, on the basis of that, you have different type of funding agencies. And it has, because this whole energy cropping on polluted lands has all these different objectives are possible. So you're not joking, you're just focusing on one objective more than on the other. And if you can focus on rural development, job creation, poverty relief, especially in really developing countries like Vietnam, you can also focus on the decrease of the use of fossil fuels and the emission of greenhouse gases. Then you have another interested party. You can promote the use of local energy sources. You can focus on environmental protection, soil improvement, erosion control, even the soil biodiversity. And you can focus on creating business opportunities, local until international. And on the basis of that, you choose the possible funding. For example, international organizations normally have money available for that. For example, the Global Biomass Fund is subsidizing projects in the field of sustainable use of biomass. International organizations, big international organizations can do this, but then normally as part of a big project, so it's only a building block of bigger projects, because they like to have projects of hundreds of millions of dollars, and then you can, in collaboration with others, you can try to put some building block on this issue inside the bigger project, as part of a bigger project. And examples are the World Bank, Global Environmental Facility, they have a lot of money, Asian Development Bank, and there's also, I think, an Inter-American Development Bank, but I don't know. You can also focus on commercial companies, but then of course you have to introduce their a potential economic benefit, profit in the future. And but if commercial companies are not that much interested, they can get more interested by giving some subsidies. There are subsidies from for example, the UNIDO, the United Nations Industrial Development Organization, just to incentivize companies to do things like this. And of course, there are the research funding organizations like the European Union, Academies of Sciences, National Research Fields, yes. Development aid organizations, UNDP, relevant ministries or NGOs. Now I say I just put a few points in which I think collaboration is possible, but it's absolutely not complete. That I would like to have in one of the next few days, maybe have some discussion with a few of you. Possible topics would be on polluted, degraded land management and land use planning. When you have big areas which are polluted, not possible for real soil remediation, maybe possible to collaborate. Capacity building, it means knowledge exchange and international capacity. We have the experiences from the past that there was in fact capacity building, starting the laboratory facilities here, to see what's coming up. Could do also something like that. Work on phytotechnologies, phytoremediation, food crop safety, a little bit further on is biodiversity, soil erosion control. But like I said, there are many other possibilities, but it should be somebody have an idea. Thank you for your attention and for your patience.
just a question regarding the difference between using something like a cover crop to do ecological restoration versus something like a biofuel. Have you looked at the impact of the harvesting period on remobilization of contaminants?
The harvesting period, that's the impact of, you mean the impact of
the harvest itself, yeah.
Mobilization of heavy metals once again inside the soil. In the case of the big grasses, vetiver grasses, miscanthus, that's not a problem because the local system stays there and the material is taken off, so we don't expect any effect. With the others, there might be an effect, especially with the sugarcane and the sweet sorghum, because that are not perennial plants. There it might be a problem, but I think that the problem will also be smaller than if you do nothing. So, but anyway, I see this problem. It's not only the direct shock effect of the harvest, but also the period in which the land is bare nothing. So I'm more in favor of this vetiver grass, this miscanthus grass, and possibly Jatropha and Ailanthus, possibly in combination with the grasses. I'm much in favor of the grasses and the oil. So I'm not in favor of sugarcane. Sweet sorghum.
More questions? Yeah, I heard you have worked in the Netherlands with remediation for organic, micro-organic pollutants. Are you not doing that in China?
No. And I have not been working so much on that. I think it was mainly your Harmsen working on PAHs and petroleum. But there is some, because I was in my function not as a scientist, but as representing this Netherlands Soil Partnership, I have also contacts in the field of organic pollution. For example, this Guoguanlin you spoke with in Beijing, they're mainly focusing on petroleum pollution, pesticides, pollution, and so on. The institute I'm working in Nanjing also has projects at the moment solving problems created by defunct pesticide factories, countryside. So I know something about that too, but all I didn't work with, what I did was especially analytical protocol, look at behavior. Like we did this Parai-Pusul project, just to study the fate and behavior of heavy metals, but not really doing something on treatment of organic polluted land, water, sediment.
Thank you for this very interesting presentation. Question, have you looked to the substance flow of heavy metals if they go into the plants, then finally when you have then the use as energy plant going into the ashes, and if this would need a special care then for management of the ashes, because today when you have biomass ashes, normally we want to bring them back somehow. And the second consideration about the substance flow is polluting then food supply when you don't take care that for some of the crops which can be used for food supply and for biomass, yeah, that you have to take care that it not come into the food cycle.
The second part I didn't understand too well, but maybe I can answer the first part about the ashes. One of the objectives of the studies we did with this with this energy crops is just to see how we can let the plant grow very well, as good as possible, without too much cost, so using waste materials, and also to reduce the uptake of heavy metals by the plant. And there are some standards for that, so that
But you know there are some other approaches which actually want to use these plants for phytoremediation to clean up. Yeah. So
you cannot do both things at the same time. You have to choose. In certain situations you can use phytoextraction, and that's in very specific situations, and absolutely cannot be used in cases like this Tongling, because it takes you 10,000 or 200,000 years to clean it up. Whatever some people like Blaylock are saying. But for example, for this Fuyang area, it could be another option, an alternative. But the problem is if you have the phytoextraction, then it use the plants to take up as much as possible from the soil and then treat the material. Then you have also this problem you're mentioning. If it's take up really a lot, then you don't have a problem because then you can send it back to a metal smelter. If it takes up not too much, your phytoextraction is not effective. If it takes up something intermediate, you can have problems with burning the things. So I think the problem you indicate is more with phytoextraction than with this phytostabilization, because it's really meant to reduce, to have, and on the other hand, it's even so that probably the oil producers like Japenga and biodiesel, the ethanol producers, it's very easy. It's normally the heavy metals don't go inside the sugar and go inside the oil. They stay in the leaves, the stems. And if you don't use them, then you can also avoid any problem. I think it's not a major problem, but your second part
Yes,
of the question.
the second question was if you plant on these polluted areas also plants which can be into the food cycle, like your sugarcane. Yeah. If you see that there is a risk that food sources could be polluted, and if there are considerations how to avoid that.
You think there can be a possibility that the population will use the food anyway? There are some. It's possible
because the prices are higher than for energy plants. So.
Yeah, but on the other hand, there are experience in Jiangxi province in China, where originally the people already had this type of culture. They made sugar cane. If the sugar cane was on good soil, they used it for sugar. If it was on a little bit less, then they use it for their local cachaças. And then when it was really worse, then they used it even for burning. So they did it already traditionally, and they distinguished between that. And there is a big movement in China now for green food and so on. That they're really, the population is really interested in get healthy food. And there are even demonstrations for that in China. So it's really living with the population. It's an issue. But I don't think the risk is too big. But also depends on how you organize this energy crop production. If you make it a little bit as a local farmer who has a little bit of this, then the risk is bigger.